Hi, I'm making a video about that how a, a channel equalizer is optimized in Matlab, and then a hardware for that channel equalizer can be made, and how a Matlab code can be converted into Vhdl or Verilog. I'm going through these steps that what we can do in the easiest way, because in channel equalizer we give a set of inputs and we produce outputs, and then we compute the errors repetitively through moving through the channel equalizer, and then we uh, update the weights of the filter of the channel equalizer, and at the end we get optimized weights of the channel equalizer filter. Now when the filter gets optimized for a certain channel with a certain dB signal to noise ratio, then it is optimal for that type of channel. Then if we put those optimized weights into a hardware or Verilog or VHDL filter, then it will work like the channel equalizer without any updation. It will have an optimized weights throughout the its having the same channel and having the same parameters. Now let's move towards the we have a code for channel PSO, channel equalizer, and we are when we run this code, this is our code. When we run this code, we get our best weights, best optimized weights for our 11 tape filter, and these we convert these weights to choose complement form for hardware realization, Verilog or VHDL, and for conversion we use a Matlab built-in function that is number to binary. When we convert this to binary, then we put these numbers in the hardware for part of the channel of the filter, and here we get the coefficients. We change the coefficients uh, of the filter in the same we got from the Matlab Matlab conversions of the optimized weights for the filter. Here are the optimized weights, and these are in the hex form. We have converted these into hexadecimal form, and here we use two types of optimizers. That one is the Tlbo, and the first one is the PSO. For PSO we have this set of weights, and for when we use the Tlbo, then we have to comment the PSO type of coefficients. So it is an optimized, it is a hardware realized model, and say it can be synthesized filter that can be used as a channel equalizer. And how we get this channel equalizer, optimized channel equalizer? We got this from Matlab simulation of the channel with 30 dB SNR, and here we check that in the main code of the PSO that its SNR was 30 dB. Let's check it for here. So here all others are commented, and here the SNR signal to noise ratio is 30 dB, and we have simulated this Matlab code for this, and we can change for different this we will comment this one for, let's suppose we are doing for 20 dB SNR, then we will have to uncomment this one, the 20 dB line of code segment, and will run the whole MATLAB simulation. After that, we will convert the uh, the G best of the that we have discussed earlier, that is the best optimized vector of the weights, that is over here, the BFG best, and we will convert this to 2's complement, and then we will put it in the Vhdl code, and that is over here. The exchange code we will put over here, and then this channel equalizer will be for 20 dB SNR. If we want to put another SNR, a channel design, a channel equalizer for another SNR channel, then we will change that to the respective SNR, and these SNRs are from 5 dB for 10 dB. We can select one by one from these SNRs, and then we will run the whole experiment, and we will get the best optimized coefficients, and then we will get the convert those coefficients into 2's complement through the Matlab function, the built-in Matlab function, and after that we will put that in the Vhdl code for the filter, and when we use that filter and apply the inputs, it will be resemble to the outputs, it will get these outputs that will be resembled to the outputs of the Matlab code. That was all for the PSO. Similarly, for Tlbo, we also have the same sequence. We get here, we get the BFG best vector, and we get this vector. After getting this vector, we convert it into 2's complement for hardware realization, and then through the Matlab function, that is a number to binary. And after here it is length is over here, that is convert like it is converted like in this way. Let's suppose we have this x in this form, and we can convert it into the 2's complement of that, and we put this in the over here. In the case of the we will comment all the PSO coefficients, and will put the uncomment the Tlbo components, and will put the changed numbers that is in 2's complement over here for 11 tapes of the filter. These are from H0 to H10, and after that we can this experiment is also for 30 dB SNR. We can change the same way for different SNR values, that is from 5 dB up to 30 dB, and for each different SNR we will have to do the complete experiment again. We will first run the Matlab code. For let's suppose for 5 dB we will uncomment the 5 dB line over here, that is in this here we will uncomment this, and we will comment the 30 dB. After that we will run the Matlab code, that is optimization, and after that we will get the let's suppose in case of Tlbo we will get over here the BFG best, and we will convert it into 2's complement, and then we will place those converted values in place of the H0 up to H10 for the filter tabs. And after that it will be like a PSO or TLBO based real uh, channel equalizer. But here the difference is that we are optimizing the channel equalizer uh, outside of the real environment, and then we put that into the real environment. We are in simulation, we optimize the weights, and with the same mechanism, with the same behavior we have for the channel, and then we put that into a real hardware. So it will be faster than the than those channel equalizer. They do channel equalization at runtime. It will be faster than that because it will not doing in real time. It will not doing will not waste its time in channel equalization. It will just multiply the coefficients with the inputs, and it will produce the outputs. That will be the and the outputs will be based on the error infused by the real channel. That will be a faster type of channel equalizer. Thank you.